Hello, everyone. If you've tuned in for Woods Hole Oceanographic Institution's Ocean Encounters presentation, Geology Rocks, you're in the right place. Joining us tonight are WHOI seismometer technician Hannah Brewer, U.S. Geological Survey research geophysicist Rufus Catchings, and volcanologist Denali Kincaid. Stay with us. Hi, everybody. In just a few minutes, we'll get started with Woods Hole Oceanographic Institution's Ocean Encounters presentation, Geology Rocks, Careers Exploring Volcanoes, Earthquakes, and more. We've still got a lot of people joining us, so thank you for your patience. Hello, you've joined Geology Rocks, a Woods Hole Oceanographic Institution Ocean Encounters presentation. We have a lot of people joining us tonight, so please bear with us. We'll get started very shortly. And now please take a moment to read WHOI's land acknowledgement.
The ocean covers 70% of the globe. It gives us oxygen and food and millions of jobs. It brings joy and shapes our climate and weather. The ocean is life, and it belongs to everyone. Woods Hole Oceanographic Institution is the world's independent leader in ocean discovery, exploration, and education, working to understand and sustain one of humanity's most precious common resources. Join us today for our ocean, our planet, and our future.
Welcome to Ocean Encounters, a virtual series from Woods Hole Oceanographic Institution, or WHOI, as we like to call it for short. Tonight's event is Geology Rocks, Careers Exploring Volcanoes, Earthquakes, and more. My name is Veronique Lacapra. I'm the host of Ocean Encounters, which is now in its 6th season. WHOI's Ocean Encounters events are an endorsed activity of the UN Decade of Ocean Science for Sustainable Development. And Ocean Encounters is made possible in part by our sponsors, the Avatar Alliance Foundation and Dalio Philanthropies. Thank you to them. Thank you also to any WHOI members who are joining us tonight. You are the heroes at the heart of our efforts. Before I introduce our speakers, I want to let our Zoom audience know that they can participate in tonight's live Q&A. If you have a question for one of our panelists, please use the Q&A button on your Zoom screen and type your question in the window that appears. You might be more familiar with the chat function in Zoom, but tonight, please ask your questions using the Q&A button instead. We often get hundreds of questions, so I apologize if we don't get to yours while we're live. You can ask questions anytime, starting now. I also want to let you know that we are recording this event, and that recording will be made available on the whoi.edu website. We had more than 2,350 people pre-register to join us tonight, so you are in good company. We also have viewers joining us right now on Facebook and on YouTube. To everyone, thank you and welcome. Let's get started. Do you want to sail around the world to measure seismic activity at the bottom of the ocean, detect fault zones, and protect people from earthquakes and tsunamis? Or just geek out over cool rocks and the inner workings of our planet? A career in geology might be just the thing. Tonight, we're going to meet 3 people with very different jobs, all in geology, and talk about how they got into the field and where their careers are taking them. They are WHOI's own Hannah Brewer, Rufus Catchings of the USGS, and Denali Kincaid, who's getting her doctorate right now. Welcome, everyone. Tonight's event is all about careers in geology and the different pathways someone can take to get into the field. Before we get more into that, I want our audience to have a chance to meet all of you and hear a little bit about what you do now. So Rufus, let's start with you. Tell us a little bit about the work you do for the U.S. Geological Survey, or USGS.
Okay. Good evening, everyone. and thank you, Geology Rocks, for inviting me to join you. My name's Rufus Catchings. I'm a research geophysicist, more specifically a seismologist at the U.S. Geological Survey in the San Francisco Bay Area of California. My primary work at USGS involves earthquake research, and that focuses in on locating and understanding subsurface faults and the strong shaking associated with earthquakes. You might ask, why are we looking at subsurface faults or looking for them? But it's mainly because not all earthquake faults are visible at the surface. So there are a lot of buildings and infrastructure like roads and highway and important things like hospitals and things located on top of faults. And so if we can locate those before an earthquake occurs, then we can strengthen the buildings or do things to, let's say, to mitigate the hazard associated with it. I also do work related to seismic imaging, which is related to the earthquake faults in the subsurface. And that's looking at other hazards associated with volcanoes, landslides, and contaminants. And I also do work with evaluating natural resources like groundwater, minerals, geothermal energy, that kind of thing. I've done this work in many different places in the United States and also a lot of places internationally like India, China, Turkey, Kenya, Mexico, etc. So I find it particularly rewarding and I really kind of like the things I do. So.
Great. Let's quickly cycle back through those photos we've been looking at so you can tell us what we're looking at. So here, well, okay, that's fine. So yeah, just let us know what's going on in each of these photos.
Okay, in that photo, we're working at the Chesapeake Bay impact crater, and we have some seismometers. That instrument I'm running is a multi-channel seismometer. It gives us a chance to record the seismic waves moving through the earth so that we can figure out exactly, we were trying to determine where is the impact crater, that kind of thing. So I'm just running the seismometer at that point.
And when you say impact crater, impact of what?
The Chesapeake Bay impact crater was it was an impact from a bolide or meteor or something that hit the Earth
Okay.
about 45,000 years ago, and it's one of the major impact craters, probably the biggest we know of in North America.
Interesting. Okay, and here you're with some younger folks.
Yeah, those are, we particularly like to work with interns. A lot of those people are interns and some are senior people. And it takes a large group of people to do this kind of work. And so I was just kind of leading the effort there.
Okay. Now this is interesting because we're in the middle of a street in Hollywood, is it?
That's correct. We're at downtown Hollywood, and you can see some of the big buildings there. And unfortunately, that big building in the background there, it appears that it's located right on top of a major fault.
Wow.
And there was a lot of development planned there, and so we hope that does not take place now that we know that fault is there.
All right.
This is recently in last year, there was a major earthquake, a series of earthquakes in Turkey. And I'm standing on the fault, and you can see where it ruptured the ground. That major earthquake killed about 60,000 people in Turkey and northern Syria. And that's some of the damage from it, as you can see there. And so I've been leading a major effort, which again, about next week this time, I should be in Turkey again, trying to understand exactly what happened and how we can mitigate that type of loss, those type of losses.
Important work. Thank you, Rufus. Denali, as I mentioned, you're in the process of getting your PhD. What are you studying and what does that involve?
Yeah, so I'm a second year PhD student. I'm currently studying volcanism in Iceland. This is a photo from my most recent fieldwork there last summer. Prior to my PhD, I worked at the Alaska Volcano Observatory and as a marine geologic contractor for a bit. But I'm studying the relationship between glacial melting, which we're seeing a lot more of with climate change, and increases in volcanic activity. So that's what I'm researching for my PhD. It's a lot of reading papers and hours in the lab, but I also get to do a lot of field work, which is very
Some pretty
cool.
exciting field work from the
Yeah,
looks of it.
pretty exciting. Yeah, so this is actually field work from undergrad. The first time I ever went to Iceland was the 2021 eruption at Fagradalsfjall, which was a pretty life-changing experience to have in undergrad. And it's actually, I have a topographic map tattooed on my arm of that volcano in the photo. So
Wow. Yeah. That's an amazing shot. And you're more than just a scientist. I happen to follow you on TikTok, where you have 300,000 followers. There are another 230,000 people or more who follow you on Instagram. Most of your posts are about geology in some way. How did you get into that?
yeah, so I think the best way to start with that is to show an example clip. It's one of the most popular clips that I have on my account. So if we could bring that up first. Oh, wow. Oh my God. These are olivine-rich hyaloclastites that were erupted under a glacier. See, all the little green bits, that's olivine. The white is plagioclase. I thought I'd only be able to get clasts from down on the ground, but at some point, one of the glassy surfaces down here, and it's just here. Look, you can see the shape of the bottom of the pillows, where the glassy rind is on the surface. Because when the volcano erupts, when the lava comes out, water from the ice that is melted by the lava quenches and cools the lava so fast that it doesn't have time to arrange itself into crystals. Look. This is xenolith in the rind. And that's insane. Love rocks.
I love that.
Yeah, so that's one of the most popular clips I think I've ever posted, and I think pretty well encapsulates like the goal of the account, which is I really love my job. I didn't know geology was an option as a job, and so that's one of the drivers behind starting the account, was that I really wanted to share my experience with geology as a career with the community at large, but also specifically with other LGBTQ people. My TikTok account started primarily as an advocacy account, or really just making LGBTQ content to connect with people in my community. And once I got a fair number of followers, and they were a majority of them were fellow LGBTQ people, my literal thought process was like, oh, like I'm gay, I like rocks. Maybe other gay people will like rocks. It was the extent of the logic with that. Now the account's grown, and of course, I really welcome anyone who's interested in geology to follow and to learn everything I talk about on the account. But it started from a desire to share a very important part of my life that's brought me a lot of joy with my own community. So
That's awesome. And
yeah.
we'll get more into that a bit later in the show. But Hannah, I want to bring you into the conversation. You're on WHOI's technical staff. Tell us what that means, what you do, and where your work has taken you.
Yeah, so hi, I'm Hannah Brewer, and I work at WHOI in the Ocean Bottom Seismic Instrument Center. And so that's a picture of me in our lab, and I'm carrying one of our acquisition tubes for one of our instruments. And so basically that's just the brains of the operation. So we have about 100 ocean bottom seismographs, which go on the seafloor and detect earthquakes. And so they'll be down for about a year, and we deploy them all over the world. So there's kind of two halves of my job as a technician. So one half is in the lab, building everything, testing everything, making sure all the different various components, like that one that I was pulling off the shelf, works as it's supposed to. And then the other half is at sea deploying them. So that pictures me and some of my coworkers deploying one of our instruments. So the big yellow thing in the middle there is a seismometer, and you can't see the sensor that great in that, but it's hanging on the side there. So
Okay.
that'll go down to the seafloor for about a year, and then we'll bring it back, download the data, and we hand that off to the scientists so they make all their great conclusions and papers. And then we take the instruments back to the lab, make sure everything works again, and then on to the next cruise. So I don't necessarily do a lot with the data. It's mostly just making sure the instrument works. And
Yeah,
I've been really
enabling the
lucky.
science.
Sorry?
Sorry, didn't mean to talk over you. Enabling the science.
Yeah, enabling the science, and I love doing it. It's fantastic. I really love working with the instrumentation, and I've been really lucky for it's taken me all over the world. I've been able to go to the Galapagos Islands twice, and I've also been to there's me with a giant tortoise. And I've been to Antarctica, Alaska a couple times, Costa Rica, Puerto Rico, and a couple other cool places. But it's a pretty good list for only being in the job for 5 years.
Yeah, that's terrific. People who didn't see, we did have a geology focused episode this season, but people may not realize that there are earthquakes at the bottom of the ocean. So you're actually putting these sensors down there to detect tremors as they happen?
Yeah, so they're sensitive enough that they're gonna record earthquakes all over the world as they move through the earth. And
Ah.
so we want ones at the bottom of the ocean as well, because that's where a lot of the faults are that we can't get to. And it's a pretty harsh environment, but we make the instruments that are able to get down there.
So you've only been doing this for 5 years, but I want to ask, what do you feel like has been the biggest impact of your work so far?
I'd say not necessarily just myself, but our group as a whole, we're always really trying to put out the best instruments that we can. So because that'll just result in better data, which will result in better science. So if it's making sure we have the best sensors on the instrument, if it's making sure the entire infrastructure of the instrument can go and live at the bottom of the ocean for a year, that's part of it too, because we're sending an instrument potentially 6,000 meters down to the bottom of the ocean in the salt, corrosive water. So it's
Yeah, and
not
really high pressure too, right? Is that why they have?
yeah, it's really high pressure, about 600 atmosphere. It's not the happiest place to live for a year. So we want to make sure our instrument can survive that. And so all that combines into just creating better data for the science community. And I think that's probably our biggest impact that we're able to make.
Rufus, I want to go to you. Can you give us some specific examples of how your work on earthquake hazards and other risks and even resources is making a difference?
Well, I hope it's making a difference, but I think one of the things is like discovering previously unknown faults or finding faults in important places. For example, like I showed in Hollywood, and identifying these areas and also identifying areas that are particularly prone to shaking. If we can do that, we think that there's a lot of ability to strengthen these buildings, the ones that exist, or if they're right on top of a fault, maybe convince people to let's abandon that building, let's not use it, let's build someplace else, or whether it may be something like a water delivery system, a lot of different things that can go wrong when they're on top of a fault. And so we've been able to find a lot of those. And I'd say with respect to natural resources, we've also been able to help cities find and manage their groundwater, help them mitigate other contaminants and things like that. So it has a real world impact,
Oh,
what
well,
we're trying to do.
Denali, I know you're still early on in your career, but do you think about how your science could have an impact out in the real world, if I can put it that way?
Yeah, definitely. It's very early on in my career, but it's one of the reasons why I chose the project that I chose for my PhD is with climate change and a lot of glacial melting occurring, there is a lot of good evidence that after enough time since mass glacial melting has occurred, we do see an increase in volcanic eruptions. So looking at that relationship, the better we're able to understand that relationship, the better we're then able to mitigate against the volcanic hazards that would affect people's, very real lives who live in volcanic regions. So I really like that kind of real world tie-in of my research.
Yeah, great. I want to bring in the audience now to our conversation. My colleague Ken Costel is working behind the scenes and fielding audience questions as they come in. Ken, do we have any good questions?
Yes, we do. It was a little bit slow at the start, but people are picking up on things.
Excellent.
First of all, I think we get this with every career episode. How much math is involved in what you do in geology?
Awesome. Who wants to take that? Denali, maybe, since you're in the studying mode.
Yeah, it does very much depend on the specialty. I get this question a lot. I'll say math was one of my worst subjects in school, which is why I didn't go into something like structural geology, where you're doing a lot of those kind of calculations. I'm definitely not going to say it uses no math. It uses more math than I wish it did. But I was able to get through the math proportion of undergrad, and a vast majority of what I do is not very complicated math. It's not much more than maybe, algebra 2. So you do have to get through those required classes in undergrad, but depending on the specialty you choose, there are specialties in geology that don't require you to do a ton of math all day, every day, because that would be stressful for me personally.
There you go.
I'll
Ken,
jump in
yeah,
there
go ahead.
and
Sure, Rufus.
I'll jump in there and say, well, geophysics, it requires quite a bit of math. So, but it's doable. It's really doable.
All right. Let's go with another question, Ken.
Okay, now we know it's not all sunshine and roses. What about your job do you not like doing?
Email.
Email?
I don't like
I'm,
email.
I'm right there with you. Yeah.
But other than that, I mean, it's great. I get to go to sea and travel the world for work. So if I have to answer a few emails, I guess that's okay.
Fair
My
enough.
worst part is because I work for the federal government, there are a lot of rules and regulations and a lot of hassle there. That's the worst part.
Red tape. Denali, what's your least favorite part?
I would have to say the clean lab. There's different kinds of labs in geology. There are some that just have rocks and dust everywhere. I love those, but there's one called the clean lab where you're processing rocks in acid and everything has to be very clean, like you wear clean suits and everything. I'm very clumsy and I got into geology because I like to be dirty. So it is a necessary part of my research process, but it is endlessly stressful every time. Because it's
Oh,
acid, it's dangerous, and you don't
yeah.
want to give acid to a clumsy person, so it takes a lot of concentration. Yeah.
Okay. Now I want to back up in time and talk about how all of you got to where you are today. Rufus, were you always interested in geology from when you were a kid?
Short answer, no. As a kid, I think I was more interested in sports, and I didn't know very much about geophysics. I probably never even heard of geophysics. But I did have an interest in rocks and minerals. And as a kid, my brothers and I used to collect rocks and Native American artifacts in our family's property in North Carolina. And that's probably the likeliest earliest seed for me, interest in geosciences, just those rock collections and things like that. And then when I
Hang
was,
on, wait, before we go on, which one are you? And are all those your brothers?
I'm the farthest one on the right.
Okay.
And so then when I was in grade school, my science class, we took a field trip to some underground caverns in North Carolina, in the mountains of North Carolina, called Linville Caverns. And I just found that fascinating, and it really sparked an interest in particularly trying to understand the subsurface of the earth, what's beneath us, that kind of thing. So that's kind of how I got started.
All right, staying with you for a second. So what steps did you then take in your education and your career to get to your current position at USGS?
Okay. I attended undergraduate school at Appalachian State University in the mountains of North Carolina, not far from Linville there, actually. So there was geology all around me, and I took a whole series of geology classes and found that the science to be very fascinating. And probably the biggest hook was as an undergrad, I took a geophysics course and I discovered there are so many ways that you can see what's beneath the subsurface or get an idea. Um, then in my career, interest was really kind of cemented when I took a whole series of internships. The first was with the North Carolina Geological Survey in Asheville, North Carolina, and then with WHOI Oceanographic Institute, actually, this
Plus.
great institute. And, and then my third internship was with the U.S. Geological Survey in Golden, Colorado. And in each of those cases, I was able to do some publishing, which I actually found very rewarding. I like to publish papers, so I did a lot of that. I then attended graduate school at the Massachusetts Institute of Technology, MIT, and the University of Wisconsin-Madison, where I got my master's in geophysics, and at Stanford University, where I got my PhD in geophysics. And I had a lot of mentors that kind of helped me along. And they were Dr. Fred Webb, who was the chairman of my undergraduate geology program, Dr. K.O. Emery at Woods Hole. He was an inspiration. I co-authored my first journal publication with him. And then there was Dr. Peter Molnar at MIT, who was a research advisor. Dr. Bob Meyer at the University of Wisconsin, who was a MS degree advisor. Dr. Walter Mooney at USGS, an early research advisor. Dr. George Thompson at Stanford, who was my PhD advisor. And a really important person was Lou Bykieser with the USGS, who really recruited me into the USGS.
So lots of good support.
Yes.
Hannah, similar questions for you. Did you always picture yourself having a career at sea?
I did. I grew up in a lobstering family. That's me on my dad's boat. And I went lobstering with my dad and my grandfather and really loved being on the water. And I wasn't sure if lobstering was really what I wanted to do with it, but my dad worked with the Department of Marine Resources and Bigelow Laboratories in our hometown, and different scientists would come out on the boat with him. And I was kind of too young to help, but I was just kind of around. And that's kind of my introduction to these types of careers. And I really loved it and wanted to figure out how to be part of that. And I also got my commercial lobster license. My brother and I, who are in that picture, we both got our licenses and we still lobster on the weekends. So that's still a big part of my life, but it also led me to WHOI as well. So that was really interesting.
Yeah, and what were your next steps?
I went to Maine Maritime Academy after graduating high school. I think like a lot of people going into the ocean sciences, I thought marine biology was the thing to do. And it took me about 2 weeks to figure out that it wasn't at Maine Maritime. So it wasn't too long. So I switched to science, but I also had another major of vessel operations and technology, which is driving boats for class. So you're out on the water, you're driving tugboats, all the different ones we had at the waterfront. And then in the summers, you have to get co-ops. This is a picture of one of them. I worked on a brig, and this helps get the sea time for your license. So I have a 200-ton license as well. And I worked out on a boat in Alaska. That's this picture. It was a cargo freighter up to the various Aleutian Islands from Seattle. And I had a great experience with all those jobs. And I loved all the people I worked with, and they were all an adventure, but it did help me realize that I wanted science to be part of my life still. And so when I was graduating, I started applying to research vessels and jobs that were labs, but also had seagoing components to them to make sure I still had that part of the job. And I ended up with the OBS lab. And so I have the science and the boats now.
Yeah, WHOI is a perfect place for combining all those interests.
It
Denali,
is.
how about you? Oh, sorry, go ahead, Hannah.
Oh no, it is, and I just didn't expect WHOI to be this early in my career. I thought it might come later, if anything.
Oh, great. Denali, as a kid, did you dream of studying volcanoes?
No. I didn't know geology, much less volcanology, was really an option for a job, which I think is very common in geology. I know a lot of people in undergrad who started in other majors and switched in. One of my undergrad professors called geology a found major. So a lot of people start in something else and end up in geology one way or another. Um, I knew that I loved the ocean and I loved all things nature growing up, which is how I ended up with this volcano birthday cake, even though I had no idea I could or would study volcanoes for a living. But I'm very glad to have found it now, certainly. So, yeah, and this is me in front of an actual volcano. Ended up quite well, I
A
think.
few years later. That's
Yeah,
awesome.
just a few years later. No dinosaurs. No.
So you said a lot of people don't start out studying geology as an undergrad. Did you major in geology?
Well, eventually I did. I started off in pre-med. Pretty much everyone in my family is either medical or military, and so in my brain those were the main options that I had. And so I started off in pre-med, but over time I figured out that it just really wasn't what I wanted to do. And so I left school for a few years, and when I was ready to go back, I was like, well, I know what I don't like. What do I like? I like the ocean. And so I took an oceanography class. And in my oceanography class, they taught us about mid-ocean ridge volcanism. And I had no idea there were volcanoes, yeah, on the bottom of the ocean. The ocean floor is covered in volcanic glass, like shown here. Uh, and I had never learned that before. I had no idea that was the case. And I remember reading that exact paragraph in the textbook and being like, oh, well, that's what I want to do the rest of my life. And
Wow.
yeah, shortly after that, I was doing an undergraduate thesis on this exact, area of the ocean floor at University of Florida. So, um, it was a really amazing experience, and I ended up really lucky with the advisors I had in undergrad in terms of encouraging that passion and encouraging me to, yeah, this is Mike Perfett. This is one of my undergrad advisors at University of Florida who I did my thesis with. And then I had a co-advisor, Dan Fornari. He was a
Many of our viewers may
Yes,
recognize him.
yeah,
He's
so
a WHOI
he's
person.
part of WHOI, yeah, and so he helped collect the samples that I used for undergrad thesis, and so within 4 years of even discovering what an underwater volcano was, I'm now doing a PhD on volcanism and recently had my very first Alvin dive with Dan, so it's been pretty incredible, I would say.
Yeah, congratulations. Um, let's take some more questions from the audience. What do we got, Ken?
Okay, we just had one come in that I think is pretty interesting. Mary asks, those careers seem to be so life absorbing. Do you have time for relationships? If so, are you able to take your partners on those amazing adventures as you work?
I don't know who wants that one.
Sure, I'll jump in there.
Yeah.
Yeah, as you can see, some of the work that we do requires a lot of people. So we have interns, we have friends, we have family, we have significant others, and so anybody, we particularly like to have volunteers. So anybody who's of age and would like to volunteer, we tend to welcome them.
All right, I might take you up on that. Denali, do you have anything to add?
Yeah, I do think a lot of your friendships and relationships tend to revolve around geology because it is a very all-encompassing thing that you do. But I think it's like anything else. If you make if you make not having your whole world be your work, then there are ways to incorporate that. Work-life balance is something I think every scientist struggles with, but at the end of the day, you prioritize what you want to prioritize. So it's always been important to me to maintain friendships even outside of work, because all of your friends do tend to be at work when you work so much. Yeah, I think it is possible, but you have to make a really concerted effort to have that be a part of your life.
And Hannah, you're at sea a lot. So how does that work with hanging on to friendships that might be on land?
Yeah, I would say because I went to a maritime college, like a lot of the friends I made there, not necessarily in science, but they understand going to sea a lot. So if you can't come to certain things, they definitely get it. And my family, like if I didn't get, I wasn't at Thanksgiving last year, and they understand, and you just make the real effort when you're home to see people. And I would say kind of what Rufus was saying, when you are doing this so much, a lot of people like they become your friends. And like when I was in the Galapagos, I was with a coworker and we were able to have a fantastic time. And same in a lot of the other places we've been. We become friends and we get to travel with those people if somebody can't fly and meet you in these crazy locations that we're in.
That's great. Ken, anything else?
Yes. I was a sucker for this question as soon as it came in. Theo, age 8, asks, what is your favorite rock?
Cute.
Oh, Hannah, you lit up there. Do you want to talk about your favorite rock?
I don't know if I have a favorite rock, but that's an adorable question. I have
Denali,
one
you
that's
must have
painted
one.
like a beetle, but
It
that's
could be a favorite type of rock, not a
it.
specific
Yes,
rock.
yes, yes. What type of rock? Denali, do you have a favorite rock?
Yes,
She has a
I grabbed it
sampling.
from the shelf behind me.
Oh, look.
This is my rock I collected from that eruption in Iceland, the first one that was in the photo. And this little green bit has the minerals olivine and plagioclase in it, and it's what's called a mantle xenolith. It's what I was freaking out about in the video. It's essentially a piece of the Earth's mantle that got caught up in the molten rock, like in the crust, and got transported up to the surface. It's one of the main reasons why we know what the composition of the mantle is pieces of it get brought up to the surface. So I just think it's really cool to hold a piece of the Earth's mantle in your hand. So that's my favorite.
Well, that's pretty cool. Rufus, do you have a favorite rock?
I'm not sure I have a favorite rock, but I would say anything that has gold in it. Any rock that has gold, I like that rock.
That's good. That's good.
Understandable.
Let's do one more quick one, Ken.
Oh, whoops, sorry, you caught me off guard.
Sorry.
Geez, I don't know if this is a quick one. Um, Gary asks, he is a science teacher. He asks, what can we do to get geology and earth science emphasized more in public schools throughout the country?
Oh, that's an interesting question. Anybody have any thoughts on that? I know that's not
More
really
field
anybody's
trips?
field here, but yeah, I would say more field trips. That was my favorite part of learning ecology, was the part in the field. So
Well, for me,
that
it
would
was just
certainly help.
looking at the geology right in my backyard, learning that I had a glacial moraine.
Yeah.
Yeah, I do think something I've noticed is that it's a systemic problem, the fact that earth science isn't required in schools, but I've met a lot of earth science teachers that are very invested in giving their students those kind of experiences, but they don't know where to go or who to contact. I've been a part of some programs and talks where I literally like emailed local teachers and was like, would you let me come in and speak with your class? So I think if we were able to make it so that teachers knew who was a part of the research community and was willing to do that, if there could be more back and forth between the communities, we could very easily arrange those things on our own while working on maybe getting it to be a more concrete part of actual curriculum. But
Yeah, and I should make a little plug for WHOI that we have a lot of people, a lot of scientists at WHOI who do go into local classrooms. And actually, we've invited a number of classrooms to attend tonight. So hopefully some of them are watching right now. Um, Okay, let's continue. I'd like to dig in a little more into what it's like to pursue a career in geology. So Hannah, we talked about how you spend a lot of time at sea. How much time do you spend at sea?
It varies from year to year based on how many cruises and how long they are, but my lightest year so far has been about 2 months, and my busiest year was about 6 months, which for me, that's kind of the side I would like to be on because I just love going to sea. But it does really depend on how many cruises we have a year, which depends on how our instruments get split up between the different cruises, and then by the length of the cruise, which is how many instruments are going to be deployed and how far from the port they are. So sometimes it takes a few hours to get to the first deployment site. Sometimes it takes a week. So it varies a lot, but I'd say about 3 weeks is an average cruise.
Well, yeah, so that's a significant amount of time. What's it been like to be out there with just a small group of mostly guys, right, on these ships?
It's good. I've really had an overall positive experience, and I understand some people haven't, and it seems like we're moving towards the positive, which is really good. And I would also say I'm very used to it since I grew up in a lobstering community. My cousin Sarah and I were basically the only women in our lobstering fleet when we started, and now there's more. And then I went to Maine Maritime, which was about 80% guys when I started, and it's still not a lot more, but there's more women. And then coming to WHOI is actually the most women I've been with, but I've had a lot of really great people I've worked with and mentors. And so in this picture is my coworker Tim, who's a fantastic coworker, and he's really helped me with pretty much everything with our current job and learning electrical skills that I didn't have coming into this and that kind of stuff. And that's a group of guys I sailed with in Alaska, and they were really fantastic and fun to hang out with. And yeah, there's more coworkers from my current job about to deploy an instrument. So I think I've had a really lucky group of people to be with.
That's great. A little bit off topic, but you mentioned that you learned how to work with electrical things
Yeah.
on the job. So you didn't necessarily have to come in knowing absolutely everything.
No, and I guess for anybody that's potentially wants to be a technician, or I guess just anybody that's graduating and is worried they don't have every skill that they need, you don't need everything as long as you're willing to learn and you want to learn, then you're going to be okay. I basically got hired because I understood how to go to sea, and I was still missing a lot of the components, especially the electrical piece and how to troubleshoot instruments. And I've learned that along the way.
Denali, you mentioned how you left school for a while and then came back. So tell us a little bit more about that, how your career has gone so far.
Yeah, so far I think it's gone really well. I think the fact that I really didn't switch to geology until 2020, and 4 years later I'm able to be at the place I'm at, shows how much, yeah, this is me in undergrad, shows how much opportunity there is in geology. But it took a lot of time and investment from my mentors to get me to this point as well. Those buckets were all filled with mid-ocean ridge basalt, or morb. That was my undergrad job, was moving a bunch of rock buckets out of the basement.
So
Uh,
rock from the bottom of the ocean.
yeah, rock from the bottom of the ocean. Yeah, and so this photo here is from my most recent cruise in March, where I was collecting my own mid-ocean ridge basalt samples for my own research. So I think I've been able to go pretty fair distance in a short period of time, but there were definitely a few setbacks because I was essentially a school dropout for a few years before going back for geology. And by the time I went back and graduated, I think I had just turned 26 shortly before when I actually graduated. And coming into geology from a non-geology background and having just believing that having a career like this was possible took a lot of effort on my part and on my advisor's part. I think working with Mike and Dan in undergrad was really the first time I think I thought to myself, like, oh, I could, live a life I'm passionate about, and they really showed me that. So it's been really wonderful getting to work with them.
Yeah, mentors so important.
Make a huge difference.
So we talked a little bit earlier about how on your social media started out really as advocating for LGBTQ plus people, and then sort of segued into geology. Let's actually watch a couple of those posts.
Okay.
She smells like lemongrass and sleep. She tastes like apple juice and bean.
So for those who may not know, that was a little gay flag. So how has that been doing that kind of advocacy on social media?
Yeah, overall it's been positive. There are definitely negative aspects to it. And I think that knowing about both is important in going into any career field where you might not be in the majority in that career field. When I first started at the Alaska Volcano Observatory, which is where I am in this photo, and where I was in the second video that you showed, I nearly started crying because in their meetings that they have, I can't remember if it was weekly or monthly, but they have staff meetings, and they had a DEIA minute where they devoted that minute to educating the people at the Volcano Observatory about inclusion topics. And that was the first job experience I'd ever had where I could hope for being looked at positively for being part of that community. It felt like the best I could really hope for was neutral, but they were very actively positive about including me in that. And so I have had some really amazing experiences like I did at the observatory, but the experience hasn't been perfect, and I think it rarely is for most people, especially being as open about being out as I am on social media. People will say anything over the internet. So I've definitely gotten negative comments, and I've worked firsthand with people who very clearly were not okay with working with a gay person in that context. And I've encountered people who are in the community and who have left science because of that treatment, or chose to go down a different career path with maybe more diverse people that they would be able to work with and feel accepted by. And it's a similar scenario with being a woman in fieldwork. Vast majority of experience I've had overwhelmingly positive, met some really great supportive people. But I've also had some negative experiences, and I have had friends who have chosen to no longer pursue fieldwork or pursue alternative jobs because of how they felt they were having issues being respected as a woman in the field. So even though I've had a good experience, I also think that there are issues in the community as a whole that we need to address, and that most likely the people who are most affected by them don't usually end up having their voice, heard on these kind of discussions because they're no longer in the field. So that's one of the reasons why I like to try and make content about it, and at least keep the conversation going about it. Because if you go into a field like this, I don't want to scare people away from it. It's a wonderful field, and I've had a great experience, but I've had a great experience because I had mentors to look out for me, and I knew what to look out for. And if you don't know that it's a problem, then you don't know to look out for it when you go into it as a student. So.
Absolutely. Well, thank you for doing that. Rufus, is there anything you'd like to share with the young people in particular in our audience about your career experience?
I would say that my career experience mostly has been very positive. However, we do live in a society that's not colorblind, and so there are issues, and there probably always will be issues. It just depends on how you handle it. So I find that a lot of the more negative things were with some of the older scientists and managers from a long time ago. And I find that the newer generation that I'm dealing with are much more positive, much easier to deal with, and it becomes a pleasure to go to work when you don't have to deal with the negativity. So, yeah, I would say anybody who's thinking about a career in earth sciences, who is, say, African American or some minority group, and you're concerned about it. I think one thing that Denali said was, if you have good mentors, and seek out good mentors, or actually, I think in most cases they will seek you out. And when that happens, you can just kind of let the negativity go over your head and just ignore it. Enjoy your life.
Well, I'm glad to hear that it's changing a little bit with younger people. That's good to know. So shifting gears now, and this one is for all three of you. Is there a moment in your career so far that you're particularly proud of, or an experience that stands out for you? Denali, let's start with you, and then Hannah, and then Rufus.
Yeah, I have a couple. The first one would be that experience in 2021, going to Iceland. It was, like I
Wow.
said, very life-changing as an undergrad. And I had emailed my mentor at like 2 in the morning or something and been like, I saw the eruption on the news and was like, hey, can you help me go to Iceland? Which I feel like was a very valuable lesson in just asking, because there's no way I thought he would say yes, but then I ended up in Iceland. So, that was a very, very cool moment. And then earlier this year, when I got to do my first Alvin dive, here's me doing my Alvin dive, and I got to dive to the same East Pacific Rise, the mid-ocean ridge that I studied in undergrad. So it was a very cool, full circle
Yeah,
moment.
so for anybody who doesn't know, Alvin is WHOI's human occupied submersible or sub.
Yes. So we got to go down about 2,500 meters to collect some very cool rocks, which was amazing for me. And then I guess as far as my science communication work, I'm very proud of the messages and comments I get from people who have either chosen to go into geosciences because of content I've made, or even people who've just been inspired to go back to school or pursue whatever major does make them happy, which is what the comment in the middle is focusing on. I do try and make a lot of encouraging content about making sure you're making choices going into, your degree with what you want for your future in mind. So anytime I get comments and messages about being able to make a difference in people's lives and kind of be the example that I had always wished I had, it makes all of the internet craziness work for sure. So
No, that's great. Hannah, how about you?
I would say when I graduated, that was a really big moment. I mean, it was a lot of work, and it was Coast Guard exams, it was senior research, and I had two majors, so it was a lot of work, and I made it through that. And then I think more of like the wow moment was I went to Antarctica as my first cruise, and I always wanted to go to Antarctica, and in school I took a polar navigation course, hoping that someday that would help me get there. And then I got my job with the OBS lab, and it was the first cruise that came up, and they asked if I'd be willing to go, and of course I said yes. So that was wild to be on the peninsula, walking around with penguins and looking at icebergs, and just like, wow, I'm really here. This is incredible.
I think you mentioned that in an earlier conversation that you were the first person in your family to go to college.
Yeah, I was the first one to graduate in college, and yeah, that's pretty big. So
Yeah,
my
that's
parents are
huge.
pretty excited about it.
Wonderful. And Rufus.
Well, I've been in the field for quite a while, so there are a few when it comes to mind, but I'll just
We'll
focus
take
on a
it. We'll
couple.
take it. Yep.
Okay. Well, I've been fortunate enough to lead some very large, important scientific investigations and collaborate with a lot of scientists worldwide. And from those works, I've been able to publish or author or co-author about 500 abstracts, reports, and journal publications. So a lot of publishing, which I do like. And I just think that the work that we're doing is important, and that it'll be important for future generations. So I kind of think about that when I'm doing things. Uh, and another particularly memorable event for me was when I received Department of Interior Distinguished Service Award, which was presented by the Secretary of Interior, Deb Haaland. So that was a real highlight for me.
And I think we've talked about that you do some work that actually works with NASA maybe to look at geology on the moon. Is that right?
Well, what I'm working with now, I just started this work. There's the effort to colonize the moon, and if you do that, you have to have water. So I've been doing a lot of work for many decades in exploring the subsurface for water. So I'm doing some experiments now in the lab, and this is a picture of it, where we have the moon dust and everything would be ice underneath. So we develop, I think I have a very good method for locating ice so that we get this ice, then you can actually colonize the moon because you will have water. So
Wow.
it looks very positive.
That's amazing. All right. I'm sure this has generated a lot of questions. Ken, what do we got?
Well, almost 150 questions, and quite a few of them are focused on I'm an undergrad trying to decide what to do. I'm graduating, facing maybe grad school or a career in oil and gas field. So I'm trying to lump them all together and say, if you could go back and give your younger self advice when you're facing a fork in the road, how would you help them manage that decision?
Yeah, and that was actually sort of going to be my last question for all of you is, if that's okay. I'm glad the audience is asking it. So, if you were going to give somebody some advice about how to stick with it when the science gets hard, or whether they should even go into a career in geology or volcanology or oceanography or some other earth science field, what would you say? So let's go to Rufus first, and then Denali, and then Hannah.
It really depends on the person, but I think the future for geosciences is bright. I mean, just what I was talking about, if you're doing exploration of other planets, you're going to need geoscientists. Whatever you do in the future, nobody will survive on this earth without the earth itself. And so we need to understand it. We also need to understand its hazards. So I originally considered the oil and gas industry when I was graduating because that was a big field at that time. But just my personal opinion is that oil and gas will start to diminish, oil and gas exploration, but it's going to be around for a while. But I think there's so many more things you can do. So I never discourage anyone from doing graduate study. I think you can do an awful lot with that. And then if you decide to go into the oil industry, then you can do it again after that. So that's kind of my take on it.
All right, Denali.
I have, I would say, two main pieces of advice. The first would be to not rush it. I think that that's one thing that I learned the hard way by having to go back to school later, is that the timeline that everyone else tells you you're supposed to stick to is not a good, like, one size fits all. I used to be really self-conscious about having had to go back to school and being an older undergraduate until one of my advisors found out I was an older undergraduate, and I was like, oh, that makes sense why you're so dedicated. I do think that's played a part in me being able to kind of speed run a section of my career. I waited until I really knew what I wanted to go back to school, and even to an extent for my PhD program. I applied 2 years in a row, and the first year, my only acceptance, I wasn't happy with the fit for the university and necessarily like my stipend and the field work. And so I was like, well, this is my only acceptance, but I'm gonna turn it down and work really hard and apply the next year. And the next year I got into my top choice. I've seen a lot of people make a decision because they feel like it's their only option. But you do have time. You can do something else and take gap years and wait to go until you know that it's right for you. And so that's one big piece of advice I have. And the other would be, if you do know that you want something, don't be afraid to annoy people about it. I think a lot of people are afraid to ask for opportunity. And if you ask for opportunity, you will get rejected a lot. But if you stop asking, no one's ever going to say yes to you. It's very rare to have gotten a volcano observatory position in any sense with just a bachelor's. And that's what I did prior to my PhD. And my boss there literally told me at one point, "Oh, well, you got the position because you wouldn't stop emailing us." So, they're not usually ignoring emails. It's just they're busy and they want someone who's demonstrating drive. And if you're sending them probably too many follow-up emails, very polite professional ones, but too many follow-up emails, you're very clearly driven. So just, be your own best advocate and don't be afraid to ask for opportunity and to advocate for yourself.
Yeah, that's all great advice. Hannah, you get the last word tonight.
I guess if you're coming up on graduating, one, I'd just say, like, to myself, definitely, like, calm down, like, it's gonna be okay. And because when I graduated, I didn't have a job lined up, and that kind of, like, at the time, it really felt like a failure. And then a few months later, I had a job at Woods Hole Oceanographic Institution. Like, that felt pretty wild. And so I'd say leading up to that, maybe try different things. Like, I tried other boats and found out that I did want science in my life, and just seeing what fits for you. And if that's different courses during schooling, if it's different internships, just explore and find out what you like. And if you find out you don't like something, like, it isn't a failure. It's just another step in the whole process. So
all right.
that's what I'd say.
That's terrific. Unfortunately, I wish we could keep going because we have so many more questions that people are asking, but we have to wrap it up for tonight. I want to say a big, big thank you to Hannah Brewer, Rufus Catchings, and Denali Kincaid for joining us to talk about geology tonight and their careers. Thank you also to my WHOI colleagues who have been working very hard behind the scenes to make this event possible. And to everyone who joined us on Zoom, Facebook, and YouTube, thank you. Tonight's event was the season finale of our 6th season of WHOI's Ocean Encounters events. We'll be back again in January with more great speakers and topics. So please watch our website, whoi.edu, for more details about that. In the meantime, you might also want to take a look at the very cool merchandise at WHOI's online store. That's shop.whoi.edu. You get a 10% event discount, as always, for joining us. Just type in the discount code Geology. If you enjoyed tonight's Ocean Encounters program, you can be a part of our solution-based approach to ocean science. If you're already a WHOI member, thank you very much. As you know, a benefit of WHOI membership is receiving our award-winning Oceanus member magazine. If you're not yet a WHOI member, please consider joining so you never miss an issue. You'll get other great benefits too, and you'll be providing crucial support for our outreach and our science. Memberships start at just $40 a year. The average gift is $120, but any amount helps. On behalf of Woods Hole Oceanographic Institution, thank you and good night.
The ocean is our last unexplored, ungoverned frontier. The life support system for our planet, inextricably linked to our climate and weather, and to the lives and livelihoods of countless people around the globe. But even against the ocean's vastness, humankind can be a formidable force. What happens next demands action that is rooted in scientific understanding and unvarnished truth, because our world stands at a fork in the road. In one direction, we watch the ocean being catastrophically altered beyond its ability to sustain us. In the other, understanding outraces exploitation, and we help steward and protect this most precious shared resource. What will be the legacy of the 21st century? Together, we can unleash the world's most creative minds, passionately dedicated to ocean science, engineering, education, and policy. Together, we can provide the expertise needed to know what works and a trusted voice to present the facts as we uncover them. Together, we can shape the future. We can inform governments, businesses, and conservationists. We can generate new knowledge in service of society. We can be the catalyst for change. It is more than our responsibility. It is the defining moment of our generation. We are explorers, students, and stewards of the ocean, and this is our time.